Hello. Today we'll be going over K31a, problem number 1. So they're asking us to draw the graph of this quadratic equation by finding these three things: A, the vertex; B, the y-intercept; and C, the x-intercepts. So let's first just try to solve for the vertex. In order to do that, I'm gonna have to put this quadratic, which is in standard form right now, into vertex form. And vertex form follows the form y equals a times x minus h squared plus q, where a, h, and q are constants. So just keep that in mind. So what I'm going to do with my original quadratic is I see a like 2x squared, and I don't like that 2 coefficient, so I want to factor the 2 out. So I'm going to factor 2 out, and what's left is going to be x squared plus 5x over 2. And then I'm going to leave the 2 constant over here, outside of the parentheses, so I'm not factoring that 2. Afterwards, I need to find a number to add inside here in order to complete the square. Because vertex form, we need to complete the square. So in order to find what that number is, what I do, so I need to find a special number, let's say right here. To find what this number is, I'm going to divide my x coefficient by 2. So my x coefficient, as you can see, is 5/2, so I'm going to divide that by 2. 5/2 divided by 2 will give me 5/4, and then I'm going to square that. So 5/4 squared is going to be 25/16. So I'm going to add 25/16 over here. But here's the catch. Since I just added 25/16 here, I kind of need to subtract something because I'm not allowed to change the original expression. It's important to keep in mind that vertex form is just a way of rewriting the standard form. We're not changing the equation. So from vertex form, we should be able to multiply everything out and get the original standard form. I'm not changing anything. So essentially, I added a 25/16 inside this parentheses, and this 25/16 is being multiplied by that 2 that I factored out earlier. So essentially, I added 25/8 out of nowhere, and I got 25/8, not 25/16, because this 2 is being multiplied by 25/16. So I added a 25/8 out of nowhere. So I need to negate that because I can't just add anything to the expression. So I need to cancel that out by subtracting 25/8. And now I can complete the square. So in order to factor this, it's going to be x, and then what goes here is going to be a plus, since I see both of these are pluses, and then it's going to be 5/4. I got that by taking the square root of this number that I just added, so 2 times x plus 5/4 squared, and then 2 minus 25/8, that's equal to, if I change it to, that's the equivalent of 16/8, and then that'll give me negative 9/8. So we're there, and then that's my vertex form, so I can easily find what the vertex is. The vertex, in this case, so the coordinates of the vertex are just going to be the opposite of this number over here. So, the negative version. So it's going to become the negative version of positive 5/4. It's just negative 5/4, so that's the x coordinate. And then the y coordinate is just this outside, this number, so negative 9/8. So that's my vertex. So up here, I'm going to write negative 5/4, negative 9/8, and we can keep that in mind. And I'm going to erase, let's see, I'm going to erase this. So just keep in mind how we got vertex form. And now I want to solve for the y-intercept. So the y-intercept is defined as where on this graph does this graph intersect the y-axis? And the y-axis, all of the points are at the y-axis is located at x equals 0. So if we were to draw a graph, say this is x, this is y, this y-axis is located at x equals 0. So in order to find the y-intercept, all I need to do is plug in x equals 0 into my function and see the output y value that I get. So I'm going to plug in x equals 0 into my function, and I will get, so y is equal to 2 times 0 squared plus 5 times 0 plus 2. 0 squared is 0 times 2, which is 0, so this can cancel out. 5 times 0 is also 0, so 0. 0 plus 0 plus 2 is 2. So my y-intercept is going to be at x equals 0, y equals 2. So I'm going to take note of that up here. And then I need to find my x-intercept. So similarly to the the y-intercept, I find this by plugging in 0 into this equation. But whereas I plug in x equals 0 into here to find the y-intercept, I'm going to plug in y equals 0 to find the x-intercept. Because the x-intercept is just defined as where does the graph cross the y equals 0 line, or essentially the x-axis line, which is located at y equals 0. So I plug in y equals 0, and I need to find out what x values this becomes true. So I'm going to factor this, and I know I can factor this like this. So I'm going to put the factors of my x squared coefficient, so 2 over here, so 1, 2, and then the factors of this positive 2 over here, so I'm going to say 2, 1. If I cross these and get the sum, so 2 times 2 is 4, 1 times 1 is 1, 4 plus 1 is positive 5. I know that I got positive 5, so this is the correct factoring combination. So I'll have 1x plus 2 times 2x plus 1. So that's how you factor it, and then x would be equal to -2 and -1/2, because if I plug in x equals -2, -2 plus 2 is 0, so 0 times, regardless of what this will be, it's going to equal 0. And then similarly, if I plug in -1/2 into here, I'll get 2 times -1/2, which is -1 plus 1, which is 0. So 0 times anything, so regardless of what this is, 0 times this number is going to equal 0. So that is going to be my x-intercepts at x equals -2, 0, and x equals -1/2, 0. So let me write that out real quick. Just check that my work is good. And then now the question wanted us to graph this this parabola using these specific points. So I'm going to go ahead and just plot a few coordinates. I'll say 5 units up and down, 5 units left and right, something like that. And I'm gonna go ahead and plot my y-intercept, so 0, 2. I'll put that right, do that in blue, 0, 2. I'll put my x-intercept, so -2, 0 is right here, and then -1/2, 0 is right here, and then my vertex is at -5/4, -9/8. -5/4 is around -1 1/4, and then this is around -1 1/8. So around here, I'll put that in blue, sorry, like that. And then now I can just trace a general sketch of this graph. Doesn't have to be perfect, as long as it looks somewhat like a parabola. And yeah, that'd be it for that one. And yeah, that's it. Alright, good luck. Bye bye.